So what we can say, when the people used to go, or scuba diver used to go inside the, you can say, in very deep inside the water. So what was happening? The pressure over them was increasing. So at that time, nitrogen used to be, because in that cylinder, oxygen plus nitrogen both is there. Oxygen is getting dissolved, no issue. But nitrogen also started to get dissolved into it. Because once oxygen is going there, so oxyhemoglobin, it is reacting with hemoglobin to give oxyhemoglobin. But nitrogen is not reacting anything, because it is not reacting here. Na? But that gets inside there. Once it gets inside there, what will happen? Okay, वहाँ पर तो pressure ज़्यादा है, तो they are very small, and there will be no problem. But once the scuba diver used to come outside or come up, what was happening? The pressure was decreasing, because inside the water pressure is high. As they come out, pressure was decreasing. As the pressure was decreasing, the nitrogen gases which were going inside the bloodstream, they used to start becoming larger, and there used to be bigger, bubbles were starting to form inside the vessels, or whatever the blood vessels we have. And then it was causing many times to, sometimes it used to go inside the bloodstream, inside the mind. So it used to do like brain hemorrhage and many things like. So it is also known as Bent's disease. And third thing is mountain climbers, that is anoxia. As we go at higher heights, what happens? The pressure decreases, because there the pressure number of, or you can say moles of gases, as we go upside, it will keep on decreasing. I hope you all know that. So as the people go at the higher heights, the pressure over them, or on there, becomes less. So the pressure, or you can say that oxygen partial pressure also becoming less. So here that is very high oxygen partial pressure, but there partial pressure of oxygen is less. So in such case, people has to work a lot for gaining that oxygen. And in that whole phenomenon, sometimes what happens, that people start hallucinating. Why? Because of the lack of oxygen. Because once the oxygen is less, whole physiology will be damaged, or you can say the whole physiology will be, you can say that will not be working in its most or maximum capacity. So what happens? That people start hallucinating, people start becoming very much lethargic, people start becoming so these things are there. That is anoxia, that is lack of oxygen. So these things are all the applications of Henry's law. Next, vapor pressure. What is vapor pressure? Always remember that before vapor pressure, I would like to tell you about evaporation. What is evaporation? Evaporation is nothing but that liquid, when converts into gas at any temperature above freezing point and below boiling point. So above freezing point and below boiling point. Let's say take the example of water. What is the freezing point of water? 0 degrees Celsius. What is the boiling point? 100 degrees Celsius. So in between 0 to 100 degrees Celsius, at every temperature, water keeps on converting into water vapor. But as the temperature increases, the more and more evaporation takes place. So what we can say? Always remember that. And what is this evaporation? Evaporation is a surface phenomenon. Evaporation is a surface phenomenon. What is this? It is surface phenomenon. But it should be a closed vessel. If it's, let's say, water is there, water will keep on converting into water vapor at every temperature. So here it is liquid, here it is gas. So after sometimes what happens? Whatever the gas is formed there, that will have the equilibrium with the amount of liquid that is inside at any given temperature. So at this point, whatever is pressure due to this gas, whatever is the water vapor on the surface of the liquid, that pressure is known as the vapor pressure. So what we can say, at any given temperature, at the equilibrium of the liquid and the vapor phase, whatever the pressure of the vapor over the surface of the liquid is there, that is known as the vapor pressure. Yes or no? So when it is defined, so vapor pressure is defined at equilibrium of vapor phase and liquid phase. So it is what? So at that time, whatever the pressure is there, that will be known as the vapor pressure of that liquid at given temperature. Why am I writing temperature? Because as the more the temperature will be there, the more the vapor pressure will be there, because the more amount of vapors will be formed. So understand these points as there will be important. Now I would like to tell you about factors affecting evaporation and factors affecting evaporation. Always remember, evaporation depends on everything like temperature. The more the temperature will be there, so we can say evaporation is directly proportional to temperature. Evaporation is inversely proportional to pressure. Evaporation is directly proportional to surface area. These things. Evaporation is directly or inversely proportional to intermolecular forces of the whatever the liquids are there. Now the more the strongly bonded it will there, the less will be the vapors formed, the lesser the vapors will be formed, lesser will be the evaporation. But what about vapor pressure? Why it is happening? Because evaporation is a surface phenomenon. Surface phenomenon. It only takes on the surface, never in the bulk. Please remember, it only takes place from the whatever the surface molecules are there. Bulk inside the liquid, whatever the molecule is there, evaporation does not take place from there. Evaporation only takes place on the you can say surface. What about factors affecting vapor pressure? What about this? Always remember, it only depends on two things. One is temperature. What is that? Vapor pressure is directly proportional to temperature. So more the temperature, more will be the vapor pressure. Second thing, vapor pressure is inversely proportional to intermolecular forces. That's why we see that vapor pressure of HF less than HCl, because HCl has only van der Waals forces, but here in HF there is hydrogen bonding, because we know that hydrogen bonding is stronger than van der Waals forces. So therefore HF has the lower we can say, they do not easily get evaporated, so therefore their evaporation will or vapor pressure will be less. Next, come to the Raoult's law. What this Raoult's law says, first of all, just know what is the you can say whatever is this definition or that statement. Later on we'll go to the main thing, that is its application. Vapor pressure of any ideal solution and non-volatile solute of a non-volatile solute, matlab whatever the solute you have put into it, that has, you can say, it has no tendency to get evaporated, or you can say vaporized होने की tendency नहीं है. It is equal to the vapor pressure of the pure solvent at that temperature multiplied by its mole fraction. So basically what we can say, so P solution equals to X solvent, because only solvent is something that is pressure किसकी वजह से होगा? Pressure will only be due to the something that is volatile. If something is non-volatile, it will not add up in the pressure, right? Because it will not converting into vapor, so it will not add up into the vapor pressure. Yes. So P, that is vapor pressure of the solution, it is here it is written vapor pressure of the solution equals to X solvent, that is mole fraction of the solvent multiplied by vapor pressure of the pure solvent. So here we are talking basically about the, when we are talking about non-volatile solute, so it is generally solid. Generally it is solid, because generally solids are non-volatile, right? Understand it. So what we can say, chalo come to the main and next point, that is vapor pressure of the liquid solution. Consider a solution is containing two parts. One is, consider there is A and another part is A and another is B. So consider mole fraction of A. X is nothing but mole fraction of A in liquid solution. And what about B? XB. Consider XB will be mole fraction of B inside liquid solution. So in such case, of course, the pressure will be due to A as well as B. Consider B is consider B is, I'm writing in. So B also have some vapors and A also have some vapors. Okay. So both of them will have their vapors. So here the vapor pressure, here P total, that is total vapor pressure, it will be due to PA as well as PB. So the total pressure will be due to vapor pressure of A as well as the vapor pressure of B. Now how much is PA? From there, the last thing that we have studied, this form, we will directly see. Here solution contains A and B, both volatile, volatile. Why both volatile? Because both of them are liquid, liquids. So what we can say, P total will be equal to PA plus PB, and it is equal to what? Pressure of the solution equals to X solvent multiplied by P naught of the solvent. When we are taking the pure solvent, then how much is the vapor pressure? Same thing we are going to do for A. It will be P naught A multiplied by XA plus P naught B into XB. So it is what? P total. Now here, what is P naught A? It is the vapor pressure of pure liquid A. While here, what is this? It is vapor pressure of pure liquid B. And we have already seen what is XA and XB. There it is written. Not a big deal. I hope it's very easy to understand. Now there is a graphical representation for Raoult's law. Consider that A, that is P naught A, is less than P naught B is more. So basically it is what we consider, that volatility of B is more than A. So if then what will happen? P naught B will be more than equal to P naught A. So what we can say, that pure B solvent will be more volatile than pure A solvent. Yes or no? Simple thing. Because B is more volatile, so therefore more vapor will be formed. So in such case, how do we make that? The whole relation is there, something like that. Consider if you are making mole fraction versus vapor pressure form. So it will be very easy. I hope from here you can see P solution and X solvent. How it goes? It's something goes like that. Yes or no? If let's say for XA, let's say it is for PA. So PA and XA will have something like that only, right? You understand it? So here what we can say, PA and XA, P naught A, it is what? PA, and here it is what? PB. That is vapor pressure of A, and here it is vapor pressure of B. If you just try to make it with respect to XA and XB, you see XA and XB, and if you add both the graphs together, you will get the P total, that is P total equals to PA plus PB. From here basically this graph is coming like that, because P total equals to PA XA plus PB XB, and we know that because both of them are solutions. So I have already told you that sum of all the mole fraction of different components inside a solution is equals to 1. So what we can say, XB will be equal to 1 minus XA. What we can say, P total will be equal to P naught A into XA plus P naught B into 1 minus XA. What we can say, P naught A minus P naught B into XA plus P naught B. Can you see now how it is looking like? It is something looking like y equals to mx plus c. It is what? Y, and because we want it with respect to A, that is what? A. It is what? It is nothing but it is m, and it is what? C. That's why the total P total has the graph like y equals to mx plus c. What is this? It is the c part, that is the, you can say, intercept on y axis, and whatever is the slope is nothing but P naught A minus P naught B. So that is what we can understand from here. Next, and one more thing we have to understand, because here it is P naught A. P naught A matlab, there it is the pure A. Here it is what? Pure A. When will be pure A? When there will be no B. Jabki pura ka pura kya ho? Solvent, there is only A. So whatever the pressure will be there, that will be due. That's why it is what? Here XA equals to 1, while XB will be equal to 0. And think about the, if when this P naught B will be there, when there will be pure B, or you can say only B is there inside that solvent. So XA will be 0 and XB will be equal to 1. No, just if you add both of them, or you can just touch both of the points, you will see whatever we have followed or formed this, not a big deal. You can do it. Ideal and non-ideal solution. Always remember, what are the ideal solution? Ideal solution are those solutions that follow the Raoult's law, while non-ideal solution that do not follow the Raoult's law. Now in non-ideal solution also there are two types of violation of Raoult's law. Either one will be positive violation or it will be negative, or positive deviation and negative deviation. Ideal solution, they obey Raoult's law. Non-ideal solution, they do not obey Raoult's law. Simple one, right? delta H mixing equals to 0. So no heat is either absorbed nor any heat is released. So delta H equals to here 0. While here delta H mixing is non-zero. Delta H mixing is non-zero. What we can say means after mixing A and B, there will be either some amount of heat will be released or some amount of heat will be absorbed. Always remember. So heat is absorbed or released during the dissociation. When and what? Always remember, if positive deviation is there, so delta H will be positive. If there is negative deviation, for negative deviation, delta H will be negative. Not a big deal. Next, come to the volume change. After mixing, do they change the volume? Yes or no? Let's see. For ideal solution, once you mix A and B, let's say 50-50 milliliter. If they are ideal solution, to 50-50 100, the solution will be just 100 milliliter. So delta V will be 0. So there will be no change in volume. So the total volume of the solution is equal to the sum of the volumes of the pure liquids mixed from the solution. So delta V here is 0, but here delta V mixing either will be more than 0 or less than 0. When more than 0 and when less than 0. Chalo check karte hain. So always remember delta V is more than 0 for positive deviation solution, while delta V is less than 0 for negative deviation solution. What do I mean to say? Consider 50-50 milliliter हमने डाला and the overall solution became 110 milliliter. So 50-50 add करने पर 110 कैसे हो गया? Because of course there is some volume is increased. So then it will be positive deviation solution. Consider करो 50-50 milliliter डाला, but that final solution became 90 milliliter. Why? Why the overall volume has decreased? It should have been 100, 50, 100, but it has decreased. Why? Because there is negative deviation. Please always remember these things. Next, for an ideal solution, PA equals to P naught A XA, Raoult's law. But for non-ideal solution, PA is not equal to P naught A XA. Always from here also remember, PA is greater than P naught A XA. P naught A XA for positive deviation, while PA is less than P naught A XA for negative deviation solution. Not a big deal, easy. Then components of ideal solution can be separated in pure form by fractional distillation. So for ideal solution, fractional distillation, so you can separate them, but for non-ideal solution, you cannot separate them with the help of fractional distillation. Please remember that, very important. One more point I would like to add here, in ideal and non-ideal solution, few more things in fact, ideal and non-ideal. What we can say, for ideal solution, delta S mixing is going to be more than 0, delta G mixing is going to be less than 0. What about non-ideal solution? This does not change in here also. So delta S mixing will be more than 0 here also, while delta G mixing will be less than 0 here also. So here also please remember delta S mixing is greater than 0 and delta G mixing is less than 0. So what did I say? Because either it is ideal or non-ideal, they are mixing by themselves. So delta G is negative because it is spontaneous process, and delta S mixing because we know that entropy is directly proportional to number of moles because it is an extensive property. So if you mix something, of course the moles is increasing, so therefore entropy will also be changed. Array, simple thermodynamics, we have already studied about it, right? Next, what are the mole fraction? What is that mole fraction and that graph? We have already seen that. It was what? It was for, I think remember, ideal solution. It was for ideal solution. And what about this? This is the positive deviation solution. Can you see? Ideal line is this, but it is going above this. It is going above this. Can you see? So it is positive deviation solution. It is what? Negative deviation. It is negative deviation solution. I hope it is very, very, very clear to you. Not a big deal. Azeotropes. Always remember what are these azeotropes. Question sometimes comes from here. I will tell you the one main point. Nothing more than that you need to know. But still, basics you have to understand. Binary mixture having same composition in liquid and vapor phase and boil at a constant temperature. So these are those kind of binary mixture. Jisme mole fraction inside the liquid and in the vapor, both of them becomes constant. So whatever you do, it is not going to change. Next. Not possible to separate components by fractional distillation. So you cannot separate them with the help of fractional distillation, but we have to use a different kind of distillation that is also known as azeotropic distillation, where you have to use. So it's a completely different process, though it is not that much important for you right now. Next, there are two types of azeotrops called minimum boiling azeotrope and maximum boiling azeotropes. Minimum boiling azeotropes, where the boiling point of mixture is less than boiling point of both component. But here maximum boiling azeotrope is where when boiling point of mixture is more than boiling point of both components. When it is shown, now it is very important, please keep in mind, third point is very important. Minimum boiling azeotrope, large positive deviation. So large positive deviation, even more important relation. Minimum boiling azeotrope show large positive deviation, that is 95% ethanol water mixture. Maximum deviation azeotropic mixture, large negative deviation. So what we can say, whenever there is negative deviation, so solution is there, it will show minimum boiling azeotrope, while maximum boiling azeotrope. But if there is a positive deviation solution is there, it will show minimum boiling azeotrope. Please keep in mind, very important thing to keep in mind. Question यहाँ से आते हैं. Now where to see all these examples? Please NCERT एक बार check करो. Maximum and minimum boiling is not maximum and minimum boiling point azeotropes, but also that positive deviation, negative deviation solutions. Very important to keep in mind. Please go through these things. We will solve though many of the questions we are going to solve. With that you are going to understand. Next, which of the following statement is correct regarding a solution of two components A and B exhibiting positive deviation from ideal behavior? Consider if there is a positive deviation, what will happen? Intermolecular interaction force between A and B are stronger than those of between AB. Yes, that is correct. Always remember, in positive deviation solution, the intermolecular force of AA and BB are more than intermolecular forces of AB, while for negative deviation solution, intermolecular forces of AA and BB are going to be less than intermolecular forces of AB. Keep in mind, very important. Delta H mixture equals to 0, no. B is 0, no, it is for ideal. Intermolecular attracts, just opposite, don't. The mixture that forms maximum boiling azeotrope. Maximum boiling azeotrope means it should be having a negative deviation solution. Please remember, negative deviation solution. Heptane plus octane, no, they are almost ideal. Water plus nitric, they are negative deviation. Achha, of course we want negative deviation only. Ethanol plus water, positive deviation. Acetone plus carbon disulfide, positive deviation. So neither this nor this, only P is going to be the correct answer. Okay, next we are going to talk about introduction. Just a minute. Introduction to colligative properties. Very important. What are the colligative properties? Those properties of the solution which are dependent only on the number of particles. That only depends on the number of particle of the solute inside the solution. The more the solute particle will be there, the more those properties will become. Okay. Now in the solution, not dependent on the nature of the particle, that is shape, size, neutral charge, whatever it is, doesn't matter. If the particles are more, that's it. Those properties will increase. What are those properties? I hope you all know that there are four you can say properties are there, or colligative properties are there. First one is relative lowering of boiling vapor pressure, that is RL Vp, relative lowering of vapor pressure. Next one is that is increase in boiling point, that is also known as elevation in boiling point. Second one is going to be decrease in freezing point, or also known as depression in freezing point. The fourth one is going to be osmotic pressure. How we just show them? Relative lowering of vapor pressure, that we also write RL Vp here. EBP, we will write it. We'll write it here DFP, and here we'll write OP, that is also pi. How do you write RLVP? Because we do not have that much time that will go in depth into it. So always remember, RLVP is shown by P naught minus PS divided by P naught equals to mole fraction of solute. What are these things? P naught is nothing but it is vapor pressure of pure solvent. PS is vapor pressure of solution. We know that if you add any of the non-volatile solute, what will happen? That non-volatile solute will take some part on the surface. So from the surface, if there was pure solvent, so there will be all the molecules will be converting into vapors. So the vapor pressure was more. But once you make this a solution, after putting some solute into it, the solute will take up some of the space on the surface. Now, if that surface is taken by some of the non-volatile particle, let's say 20 part of the space is taken by non-volatile particle, only 80% will be converting into vapor, because volatile part, that is solvent, that will only be 80%. So now the vapor pressure will become less, because in the vapor pressure of the pure solvent, it was 100% of the volatile thing, right? So I hope you understand it. That's why after putting any of the you can say solute into some solvent, the vapor pressure decreases. Now we are not talking about lowering of vapor pressure, because lowering of vapor pressure is P naught minus PS, not RLVP. But relative lowering of vapor pressure, when you compare it with the initial, that was pure solvents vapor pressure. So P naught minus PS equals to, and it is what? It is excess is mole fraction of solute. Always remember, इसका दूसरा form भी है. There is another form, that is what? P naught minus PS by PS equals to number of moles of solute by number of moles of solvent. Please keep in mind, it is very, very, very important. It is coming from here only, so you can use both of them. Elevation in boiling point. Elevation in boiling point is given by delta TB equals to KB into M. That is what? Molality. What is this? Molality. What is this KB? It is nothing but molar elevation constant. Molar elevation constant is also known as ebullioscopic constant. Now what about this delta TB? I hope you see EBP. DFP is also known as delta TF equals to KF into M. Here what are these things? I hope you all know about it already. KF is also known as molar depression constant. That is also known as cryoscopic constant. So these things may be asked to you. Please keep in mind. And M is what? Molality. I'm not telling molarity. I'm telling molality. Okay. Now osmotic pressure, that is pi. What about pi? Pi equals to CRT. What is this C? What is this R? And what is this T? C, always remember, it is nothing but molar concentration. Molar. I'm not writing now molar. It is molar concentration. R is, of course, that whatever the gas constant, universal gas constant. What is this T? T is the Kelvin temperature. Kelvin temperature. And what is this pi? Pi is nothing but osmotic pressure. Keep these things in mind, and that is enough for you. That is more than enough for you. But one thing I hope you already know about, I'm going to talk about want of factor I. What is this want of factor? Dekho, what we were expecting, consider I have put some 1 mole of any substance inside any liquid. Now I would expect only that 1 mole will be whatever these things are there, that is what you say, colligative property, they will increase according to 1 mole only. But what if that 1 mole dissociates into 2 moles? Let's say AB is dissociating with A plus and B minus. So 1 particle converted into 2 particles. So in such case, what will happen? In such case, whatever the colligative property will be there, it will be 2 times. Yes or no? But whatever, so therefore, whatever we will expect that this should be the value of boiling point, elevation in boiling point, but that will not come, or any of the colligative property, it will not come. It will come different. And what if they get associated? We put only A, but later on it becomes half of A2. Basically, it converts it associates later on. Once it associates, so there will be, we will expect that we have put 1 mole, but later on it becomes half mole. So in such case, what will happen? हमने तो डाला था 1 mole, but it is giving you some different value. So in such case, what will happen? You will have a different kind of values, and you will have a data mismatch from whatever you are calculating and whatever is coming as the observation in experimentation. So for solving this problem, there came there came want of factor. Basically, there is a whole topic, though we do not have that much of time, where we talk about the abnormal molar mass and all those things. Now, just keep it aside and directly understand how do you deal with this problem. Let's say some association or dissociation is taking place. So what you have to do? You only have to multiply in the whole formula, whatever the formula we have done na. Yahan par bas what you have to do? You have to multiply with one thing. What is that factor? That is I. I is what? Want have factor. Let me just write it down in all the formulae. So P naught minus Ps equals to INS by N solvent. Please keep in mind. Next, delta TB will be equal to I into KBM into I into KBM. Delta TF will be equals to I into KFN. While here pi will be equals to ICRT. But what is this I? This I is nothing but want of factor. I hope you understand. What did I say? So please do not remember now. Do not remember these formulae directly. Always remember it them with the I, that is want of factor. Next, what is this I? That is, I have already told you, in case of it is equals to, this factor takes the count of number of particle after association or dissociation. So I equals to number of particle after association or dissociation divided by before association of or dissociation. Now for dissociation, what will be I? For dissociation, I will be equals to 1 plus n minus 1 into alpha. What is n? Now let me tell you. Consider I am taking some example, direct example. MgCl2. MgCl2 breaks into Mg plus 2 Cl minus. So how many number of ions are later on? So n is equals to 3. That is number of ions after dissociation. So what will be happening? N will be equal to 3. So in such case, what will be there? I will be equals to, what is this alpha? Alpha is degree of dissociation. So I will be equals to 1 plus n minus 1 into alpha. So 1 plus n is how much? 3. So 3 minus 1 into alpha. That is 1 plus 2 alpha. Always remember. Now in such case, one more thing always remember. If alpha is not given, then consider alpha equals to 1. That is 100% dissociation. 100% dissociation. So in such case, what will happen? Therefore, I will be equal to directly, what we can say? I will be equal to n. Why? Because I will be equal to 1 plus n minus 1 into 1. That will be 1 plus n minus 1. Cancel. So I will be equal to n. Please remember, if alpha is not given, then consider alpha equals to 100%. 1, that is 100% dissociation by yourself. Now for association, what is that? Then I will be equals to 1 plus 1 by n minus 1 into alpha. Now consider how it is working. Now consider A is there. A is going to A3. It is called trimerization. Trimerization. Okay. Now consider Na. Na converting into An, or then you will say it is polymerization. Polymerization. Now you can say 2A converting into A2. It will be called dimerization. If let's say 3 atoms associate, trimerization. I hope you understand what I'm trying to say. 4 atom tetramerization. 5 pentamerization. Very easy. Next. In such case, what will happen? Because there are 2 molecules getting associated, so here n will be equal to what? N will be equal to 2. So for dimerization, n will be equal to 2. So therefore, what will be the I value? Will be 1 plus 1 by 2 minus 1 into alpha. That is 1 minus alpha by 2. Okay. Now always remember. So what is that? Always remember one thing. If at any point of time alpha is not given, if alpha is not given, then the same thing whatever I told, consider alpha equals to 1. Then what will happen? I will be equals to 1 by n. Directly what you will consider? I will be equals to this 1 by n. Okay, not a big deal. You can just solve it. Now conclusions are what? If neither association or dissociation takes place, then consider always I equals to 1. Normal colligative property. Okay. If either association or dissociation take place, then I is not equal to 1. So association, you know, 1 plus n minus 1 into alpha. For dissociation 1 plus n minus 1 into alpha. For association 1 plus 1 by n minus 1 alpha. That's okay. Abnormal colligative property. Hence, we can write also as I equals to abnormal colligative property divided by normal colligative property. It's a very important relation. Sometimes question directly come from here. Please, so keep in mind. RLVP of 30 gram of urea solution in 1 kilogram water is X of 90 gram glucose solution in 1 kilogram water is Y. What is the relationship between X and Y? Now what it is asking for? It is asking for RLVP. Now RLVP for first solution. Consider for first solution in 1 kg of water. Water is here 1 kg and is X of 90 gram of glucose. Okay. Now it will be whatever is that, P naught minus Ps divided by P naught. It will be equals to mole fraction of glucose, because glucose is here what? Solute. So what is that? From here we can say that number of moles of glucose equals to given mass by molar mass. How much it is? 180, that is 0.5. So 0.5 divided by 0.5 plus 1 kg of water means 55.55. So 55.55. What about the second thing? RLVP. Acha, sorry. First one is for 30 gram of urea. Sorry. 30 gram. So number of moles is how much? 30 by 60. It is how much? 0.5. Acha, here also it is 0. There also it is 0.5. So rather than putting, just put urea. And here for second one, P naught minus Ps divided by P naught will be equals to mole fraction of glucose, that is 0.5 divided by 0.5 plus 55.55. I hope you can see that both of them are coming same. So what will happen here? X will be equal to Y. Not a big deal, very easy, right? Next, the relative lowering of vapor pressure in proportional to the ratio of the number of. I hope you have seen mole fraction. Mole fraction of solute, and mole fraction of solute is equal to moles of solute divided by moles of solute plus moles of solvent. Because we know that RLVP is directly proportional to mole fraction of solute, that is equals to Y directly proportional equal to mole fraction of solute, that is number of moles of solute by number of moles of solute plus number of moles of solvent. That is nothing but it is total number of moles in solution. So moles of solute by moles of, so we can say that solute moles to the total number of moles of solution. So this one only is the correct answer. Next, the freezing point in degrees Celsius of solution containing 0.1 gram of K3 in this in 100 gram of water, given that Kf equals to this. How can we solve it? Not a big deal. Chalo zara socho. Now we know that delta Tf equals to, we know that it is what? Aqueous solution, yes or no? In this 100 gram of water. So for aqueous solution, we know that normal freezing point is what? Normal freezing point is what? 0 degree Celsius. Okay. For pure water. For pure water, normal freezing what? 0. So let's find out how much of the freezing point decreases. So the freezing point of the solution. So delta Tf will be equals to I into Kf into M. What is I value? I hope it is not given, the degree of dissociation. So whatever I told you, directly use I equals to N. How many number of ions it will give? 3 potassium ion and 1 potassium ferrocyanide, that is FeCN 6, 3 minus ferricyanide, potassium ferricyanide. So 1 ferricyanide and 1 is potassium. So that is how much? Total number of ions are 4. So what is that? I will be 4. 4 into Kf into M. Kf ki value is given 4 into 1.86. What is molality? Molality, I hope you know that. What is the molality? Given moles of solute, or it is given directly the mass. So mass of solute, it is what? Mass of solute. So 0.1 divided by molar mass of solute, that is 329, into mass of the solvent. Mass of the solvent is how much? It is mass of solvent, that is how much? 100 multiplied by 1000. So please, I hope you can just do that. So delta Tf, you can solve it from here. One of these options will be there. Next, when 20 gram of naphthalatoic acid is dissolved in 50 gram of benzene, a freezing point depression of 2 Kelvin is observed. then Van 't Hoff factor I is equals to what? We can say that, we can see that it is given what? Delta TF is given. Delta TF is given. So delta TF will be equal to I into KF. KF की value कितनी दी हुई है? 1.72 into M. How much is the M? I hope you can see that. Ki what is the solute? It is the number of, it is the mass of solute. What is that? Benzene is the mass of solvent into. So what we can say? 20 by molar mass of the naphthoic acid is how much? It comes out to be 172 only. Yes. Into mass of the solute. Mass of solute comes out to be how much? Solvent comes out to be how much? 50. But it is in grams, so multiply with 1000. Cancel karo, how much it is? 20. So what we can say? Cancel it, how much it is? 100. So what we can say that 2020 is how much? Just a minute. I think it comes out to be C11 H8O2. That is how much? 172. Correct hai. So 100, then it is 400 into I by 100. Cancel. So it is what? 4I. But delta TF is given how much? Delta TF is given 2. So 2 equals to 4I. So I will be equal to 0.5. Means it is less than 1, because I is less than 1 means it is association. Means what is happening? Association, not dissociation. 0.5. Not a big deal. Easy question. On the following, of the following 0.1 molar aqueous solution, which one will be exhibit largest freezing point depression? Always remember, because delta TF is directly proportional to I KF. KF for water is always same. So I and M. तो क्या आप यहाँ पे दिया हुआ है? Molality is same. So it is, I can directly say delta TF is directly proportional to I. So if nothing is given, I will be equal to N. What is the N here? 2. N here is 2. So I will be equal to 2. Because it is what? It is glucose. And glucose is, you know it is organic solute. So if you put it into water, neither it will associate nor it will dissociate. So here I will be equal to 1, because we have already seen that I equals to 1 for no association, no dissociation. Here I will be 2 aluminum and 3 sulfate, that is 5. Here I is equals to 2 potassium and 1 sulfate, that is 3. So option C is the correct option, because we know that delta TF is directly proportional to I. Not a big deal, very easy. Next, for 1 molar aqueous solution of the following compound, which one will show highest freezing point? Same thing, but here it's a completely different question. It is asking for highest freezing point, not depression in freezing point. Dekho, always remember कि boiling point is directly proportional to elevation in boiling point. So if EVP comes more, then boiling point also comes more. But freezing point is inversely proportional to DFP, because we know that in depression in freezing point we are saying more the depression, lesser will be the freezing point. So we have to just see that where depression in freezing point is more, so there the freezing point will be less, and where DFP will be less, their freezing point will be more. Please keep in mind. How? Dekho. Here what is there? N की value it is how much? 1 complex ion will be there and 3 chloride ion. So N will be 4. यहाँ पे 1 complex ion and 2 chloride ion. तो N की value here 3. Here 1 complex ion and 1 chloride ion. H2O तो H2O में मिलके पानी पानी हो गया, पानी पानी में पानी पानी हो गया भाई. N equals to 2. Here what is there? 1 complex and water को तो छोड़िए, तो N equals to how much? 1. तो जहाँ पे N की value minimum है, तो यहाँ पे DFP यहाँ पे minimum, तो freezing point will be maximum. So option D is the correct option, because it is asking for highest freezing point. Yes or no? Now there we are going to talk about directly. No, see, we do not have that much of time. I'll just keep few points here in mind. What is osmosis? Osmosis is the process of spontaneous flow of any solvent particle, not the solute particle. I'm telling you, solvent particle through semi-permeable membrane from less concentrated solution to more concentrated solution, because in less concentrated solution there is more amount of water, while less amount of solute, while in more concentrated solution there is more amount of solute, so therefore less amount of water will be there, or less amount of solvent will be there. Always through semi-permeable membrane no solute can pass, so only the solvent will pass, because we know that solvent is more in less concentrated solution, so solvent will pass through less concentrated solution to more concentrated solution. As a rule you have to keep in mind. Or if let's say there is a solution and there is a pure solvent, so always the water will pass through solvent to the pure to the solution, as a rule. Okay, Now the spontaneous flow of the solvent particle from the solvent side to solution side, from the solution low concentration to the high concentration side through a semi-permeable membrane. So that is known as the osmosis process. Now a membrane which allows only solvent particle to move across is very important point. What are the SPMs? It is written. Now osmotic pressure is that much of pressure. Let's say osmosis is going from solvent to the solution. How much amount of extra pressure you should apply on the you can say solution, that the osmosis stops. For stopping the osmosis process, whatever is the extra amount of pressure in opposite side, that is in the solution side, you have to apply, that is known as the osmotic pressure. That is known as pi. Pi equals to I C RT. We have already seen that. What are these things? Next, this is how osmosis is taking place. It is here given. Now 200 centimeter cube of an aqueous solution of protein contains 1.6 gram of, okay, what is the volume? Volume is given 200 milliliter. Aqueous solution, okay, of protein contains 1.6 grams of the protein. Okay, mass of the solute is how much? Mass of solute is 1.26. Osmotic pressure of such solution at 300 Kelvin temperature is found to be this much. Okay, this is found to be pi. So calculate the molar mass of the protein. What is the molar mass of protein? Protein is here a solute, yes or no? Next, how? So what will happen? Will there be any association or dissociation? No, because proteins are nothing but they are organic substances. Organic substances. So in such case, what will happen? In such case, there will be neither association nor dissociation, because organic substances inside water is going to do nothing. So pi is given how much? 2.57 into 10 to the power minus 3 equals to I की value कितनी हो गई? I will be equal to 1. What is C? C की value is number of moles of solute. What is the number of moles of solute? That is 1.26 given mass by molar mass of solute. We do not know. Into, because we are finding about molar concentration, into volume of the solution. What is the volume of solution? 200 centimeter. Centimeter is nothing but milliliter. When it is milliliter, we have to multiply with 1000 into what is the temperature? It is 300. Please solve it here. From here you will get few things. Whatever is the molar mass, you will get that. So not a big deal. You can solve it from here, because here only MS has to be found out. MS is nothing but molar mass of the protein. Okay, easy. Now at the highest osmotic pressure is exhibited by 0.1 molar of solution. Again, osmotic pressure, that is pi, is equals to I C RT. RT is same for all of them. So but either I will be different or C will be different. It is given by C is same, because C is same. So it will not also depend on C. So it is only going to depend on I. Here I की value कितनी? 1. No association, no dissociation. Organic substance, no association, no dissociation. It is ionic. I equals to 3. Here I equals to 2. So where the maximum dissociation is there? There. What we can say? One more thing, always remember, if there are two solutions A and B are there, iska osmotic pressure is pi 1, iska osmotic pressure is pi 2. If pi 1 is more than pi 2, then pi 1 is known as hypertonic solution, while pi 2 is known as hypotonic solution. But what if pi 1 equals to pi 2, then both of them are called isotonic solution. Isotonic solution. Next, we are going to talk about which of the following aqueous solution has osmotic pressure nearest to that of the equimolar, means molarity again C is same. So what we can say, that pi is only going to depend on I. Here I की value कितनी? 4 potassium and 1 complex ion, that is I की value 5. Whichever has I की value 5, that will be same. It is 3. Here I की value 3. Here I की value 5. So what we can say, C is the correct option. Next we are going to talk about, choose the correct option from here. No movement of liquid. Let's say 0.1 molar KCl, 0.05 molar. So again here, what we can say, pi equals to 0.1 into ICRT into 2 RT. That is 0.2 RT. What is that? 0.15, because I की value here it is 3. 0. RT. So which is more? I think it is more, it is less. So always remember कि water will go from, but only the solvent will pass. Only the solvent, that is what water will move. No KCl or no SrCl2 will pass, because we know that through SPM only solvent pass, no solute. So no movement of the liquid across SPM. No, wrong, because water is moving. SrCl2 will flow. No. Solute does not flow. KCl, no. Assuming 100% dissociation, pi KCl equals to more than pi SrCl2. Yes, because we know that it is 0.2 RT, it is 0.15 RT. For sure, pi of this is more than this. Not a big deal. Correct one. Last question, FeCl3 on reaction with this an aqueous solution gives blue color. Okay, when this and this react, it will give blue color. Now, these are separated by semi-permeable membrane. This is the semi-permeable membrane. AB as shown, due to osmosis, there is. Acha, osmosis की वजह से क्या होगा? I think everyone we can see that here I की value is 4, here I की value is, I think K4, FeCN6, 5. So it will be 0.5 RT, while here it is what? 0.4 RT. Now I can see that 0.5 RT, 0.4 RT. So water will always, and that only solvent, that is water will pass from less concentration to more concentration. So it will go from here to here. Yes, because always the solvents goes from low concentration to high concentration. Yes, chalo. So blue color formation inside X, no blue color formation because no solute particle go, because after solute react, then only blue color is going to be formed. But solvent is passing, so solvent ke paas hone se thodi na there will be no blue. So blue color formation inside X, no, wrong. Blue color formation, no blue color formation because no solute particle can pass through. Next, blue color formation in both the sides of X and Y, no, because there is not going to be any solute to pass through. No blue color formation. Yes, it is correct, because only the solvent goes from one side to another side, never the solute. I hope that is something, whatever we have studied today, that is all, and that is very much important. If you just solve these questions and solve all the PYQs, you will find that such kind of questions are very important. Whatever the types of question we have seen, only the same type of question, no question can come out of it. So I would just give you that, I'll tell you all the best for that examination and preparation. Whatever the types of question we have seen, please go through all of them, and all the best for the preparation.